Hello. Am I audible?
Yes, sir.
Yes, sir.
Okay. So do you have any doubt from last class?
No, sir.
No, sir.
Okay. Now the next term after this is conservation of linear momentum. Suppose you have a body which is going at some velocity u1 having mass m1. Another body which is going at some initial velocity u2 having mass m2. So on collision, after collision, velocity will become v1 and v2 respectively. So during this particular impact or collision, first body would have some action on the second body. So it will be force on second object due to its first. Let's say this is action by first on second. In return, second body must have replied in reaction to first body. So force on first by second. So it will be reaction. Is it clear?
Yes, sir.
So force on first by second will be equals to change in momentum of first body with respect to time. So it will be delta P in first divided by delta T, and force on second by first will be equals to change in momentum of second body with respect to time. So net force will be F12 plus F21. So due to conservation of linear momentum states, if net force applied on the body will be zero. So sum of these two forces, which will be equals to sum of change in linear momentum on either of the two body, will be equals to zero. So if you put all the values in this part, you will get F12 plus F21 equals to zero. Move one of them to the other side. So F12 will be minus of F21. It means if this is your action, this must be reaction. And since there is negative sign, which means these two terms will be in opposite direction. Is it clear?
Yes, sir.
So this is all about third law. Now, if you put this particular value related with momentum, just write it down first.
Done, sir.
Done, sir.
Now, if you put the values of these two terms, F12 equals to change in momentum of first with respect to time minus of F21 change in momentum of second with respect to time. Now this delta t and this delta t will cancel out. Change in momentum of first body, so it will be mass times change in velocity of first body, so it will be v minus u minus of change in momentum of second body, so m2 v2 minus u2. On simplifying it further, you will get m1 v1 minus m1 u1 equals to minus of m2 v2 plus of m2 u2. Move this m2 v2 to left side and m1 v1 to right side. You will get m1 v1 plus m2 v2 equals to m1 u1 plus m2 v2, which means total linear momentum after collision equals to total linear momentum before collision. It means sum of linear momentum of a body will be conserved if there is no external force acting on the body. So you'll say this is total linear momentum of body after collision, and this is total linear momentum of body before collision. So from this we can conclude if there is no net force acting on system, then linear momentum will be conserved. Arslan, is it clear? Yes, sir. Okay. Sabita, any doubt?
No, sir.
Okay.
Done, sir.
Done, sir.
Safan, you have written?
Yes.
Now, using this formula, we may define sum of problem. First is bullet and gun. Suppose you have a gun and there is bullet in it. Before firing, it will be after firing, bullet will move along this direction with some velocity Vb. Mass of bullet is m. So there will be momentum in forward direction. In return or in reaction of that, there will be velocity in this gun will be termed as a recoiling. Let's say Vr. Mass of gun is m. So using conservation of linear momentum, since there is no impact from anything from outside, so you will say total linear momentum before firing, total linear momentum after firing should be equal. Before firing, mass of gun and its velocity, mass of bullet and its velocity. After firing, mass of gun, velocity of recoiling, mass of bullet and velocity of velocity of bullet should be equal. So if simplifying, you will get velocity of recoiling is equals to mass of bullet times velocity divided by mass of gun. So this will be our final expression for recoiling velocity of gun. Is it clear?
Yes, sir.
Yes, sir.
Done, sir.
Done, sir.
Ruslan, you have written?
Done, sir.
Okay. There will be a question. A machine gun can fire 10 bullets per second, each having mass 200 gram, emerges at 100 meter per second. Find net thrust experienced by gunman. Suppose you have there is a machine gun which can fire 10 bullets per second in forward direction. So one bullet will generate mv amount of momentum n times velocity of bullet. And if there is total number of bullet n or 10 bullets, so total amount of momentum generated by this will be n times mv. Is it clear?
Yes, sir.
Initially, when there is no firing, momentum will be 0. So P initial will be 0. P final is n into m into v. Total time taken during this particular impact is 1 second. So according to second law, force equals to change in linear momentum over time taken. Gun will apply action to that bullet to fire it forward. So there will be recoiling or backward stroke in this direction, which is thrust, which must be experienced by the gunman and which should be equals to change in linear momentum divided by time taken. Put the value of all these terms and simplify it. Is it clear?
Yes, sir.
Okay. Good, Samara. Good, Mariam. Arslan, you have solved?
Trying, sir.
Okay. If you put all the values in this part, change in linear momentum will be n mvb minus 0 divided by t. Here we have number of bullet as 10. Mass of bullet is 200 gram divided by 1000. So it will be 0.2 kg. Emerges at 100 meter per second. Divided by time taken is 1. So on simplifying, you will get 200 Newton. Safan, is it clear?
Yes, sir.
Okay. Similarly, there will be problem for decaying of nuclei or splitting. Suppose a nuclei initially at rest. So due to internal effect or internal energy, it will split up in two different fragments. Let's say these two terms. Now, initial mass of this nuclei is m. So this will be divided into two parts. So this will be M1 and this will be M2. Since nuclei is initially at rest, so total momentum of this nuclei will be 0. So the sum of linear momentum of these two bodies must be 0, due to which these two bodies will move in opposite direction. So this will move at some velocity v1 in left hand side, and this body will move towards right hand side with this much velocity. So momentum final for these two terms will be m1 v1 in negative plus m2 v2 in positive. According to conservation of linear momentum, this should be equals to 0. Or if you rearrange it, you will get m1 v1 equals to m2 v2, means p1 equals to p2. Is it clear?
Yes, sir.
So remember this thing. Whenever a nuclei is split up into two parts, momentum of either fragment will be equal to each other and it should be in opposite direction. So that the total momentum before splitting or decaying should be equals to total momentum after should be equal. Arslan, is it clear?
Yes, sir.
Okay. A boy of mass 60 kg is running at 14 meter per second, jumps on stationary skateboard, find velocity of combined if mass of skateboard is 10 kg. This is opposite of the above part. In above part, a nuclei is splitting into two parts. In this term, two different bodies are combining to form single system. Since there is no any external force acting on this particular system, so linear momentum will be conserved. Total initial momentum should be equals to total final momentum. Just equate them and try to find. there is a boy which is running along this direction, skateboard, which is initially at rest. So total momentum before and total momentum after should be equal. Mass of boy, velocity of boy, this will be initially at rest. Total momentum will be 0. Mass plus mass into V. Just put the value of each term and simplify it to get the value of V. Sabita, just check your calculation. Mariam, just check your calculation. Mass of boy is 60 kg. Mass of a skateboard is 10 kg. Initial velocity is 14 meter per second. Good, Samira. You have to find V. Mariam, just check your calculation. Mass of boy is 60. Velocity is 10 equals to 60 plus 10 into V. No, velocity is 14 meter per second. Sixty plus 10, it will be 70 times V is equals to 60 into 14. Move this 70 to left hand side. You will get velocity equals to 60 into 14 divided by 70. This 0 and this 0 will cancel out. 7 into 2, 14. 16 into 2 will be 12 meter per second. Is it clear?
Yes, sir.
Arslan, is it clear?
Yes, sir.
Aisha, do you have any doubt?
No, sir.
Okay. A bullet of mass 100 gram is fired at 150 meter per second. towards a stationary block of mass 2 kg. If bullet emerges out at 100 meter per second, find velocity of block. Suppose a bullet fired along this direction at some initial velocity u. There's a block in its path. So bullet will penetrate into it and then emerges out at some velocity v, which is 100 meter per second. So this block will have acquired some velocity, let's say v1. So according to conservation of linear momentum, you will say total momentum before and after should be equal. Initially, only bullet was moving, so mass of bullet into its velocity. Block was initially at rest, so it will be 0, equals to mass of block into its velocity plus mass of bullet, velocity of its emerging. So we have to find value of V1. Mass of bullet is 100 gram divided by 1000 to convert into kg. Initial velocity of bullet is 150 meter per second. Emerging out velocity is 100 meter per second. And mass of block is 2 kg. Just put these values in this equation and try to find the value of V1. Do you have any doubt in this problem to any one of you? Safan?
No, sir.
Okay. Try to solve. Find the value of V1. Good, Samira. Good, Mariam. Sabita, just check your calculation. Safan, check your calculation. Here we have mass of bullet, 100 gram, divided by 1000. So it will be 100 by 1000. Velocity of bullet is 150. Mass of block is 2 kg. Velocity is V1. Mass of bullet is 100 divided by 1000. Velocity of emerging is 100. So this and this will cancel out. This and this will cancel out. So it will be 15 is equals to 2 times V1 plus 10. Move this 10 to the other side. So 10 minus 15 minus 10 will be 5 equals to 2 times V1. So V1 will be 5 by 2. That is 2.5 meter per second. Arslan, is it clear?
Yes, sir.
Sabita,
Yes, sir.
is it clear?
Yes, sir.
Okay. You all have written?
Yes, sir.
So this is how we approach this particular conservation of linear momentum and try to define different problem. Next is concurrent forces. So first, what do you mean by concurrent? Samira, do you have any idea? What do you mean by concurrent? You must have learned this particular term in class 9th in mathematics in chapter number 5 about Euclid's postulate. It was about concurrent lines. Suppose you have a point, single point. You may draw infinite line to this single point. So all the point or all the line which are passing through this single point are termed as concurrent lines. So in terms of forces, you will say if a large number of forces are acting on a single point, so all the forces are termed as concurrent forces. A large number of forces are acting on single point. Let's say F1, F2, F3, F4, F5, F6, and so on. Is it clear?
Yes, sir.
And we have to define equilibrium of all these forces. It means equilibrium of concurrent forces. If sum of all forces acting on a particular point sum up to 0, this will be termed as equilibrium of concurrent forces. Now we have to mainly define up to maximum of 3 forces. Let's say you have 3 forces, F1, F2, F3, acting on this particular single point. Angle opposite to these forces, alpha, beta, and gamma. So there is a relation in between these 3 different terms, which I have already defined you in vector part about Lemmy's theorem. Mariam, would you explain Lemmy's theorem? If sum of all forces acting on a single point sum up to 0, it means these 3 forces will form a closed loop. So in terms of vector, a number of vectors arranged to form closed loop will give you resultant as 0. So it will be F divided by sine of opposite angle equals to F divided by sine of opposite angle, F divided by sine of opposite angle. So this is Lemmy's theorem. Is it clear?
Yes, sir.
Sabita?
Yes, sir, it is clear.
Okay, just write it down.
Done, sir.
Done, sir.
Aslan, you have written?
Yes, sir. Done.
Okay. Suppose there will be a question, a string along this side, another along this side, and there is a mass attached with this. Inclination at this point is 30 degree. So we have to find tension in this string if mass of this block is 5 kg. Find tension in each string. So how to define it? Let's say just draw a vertical line and horizontal line. There will be tension in this string along this direction, T1, and there will be tension in this direction as T2. So this angle, which is alternate of this particular term, so it will be 30 degree. So if you resolve component of this T1 with respect to this theta, this horizontal component will be T1 times cos 30 degree, and this vertical component will be T1 times sine 30 degree. There will be a force due to this block in downward direction, that is mass times gravity. Is it clear?
Yes, sir.
Since the net force acting on junction is 0, so total upward force must be equal to total downward force. So along x-axis and along y-axis. So along y-axis we have T1 sine 30 degree equals to m into g. Put the value of gravity to be 10. Sine 30 is 1 by 2. Simplify it, you will get T1. Similarly, for horizontal line, T2 equals to T1 times cos 30 degree. From this first equation, try to find the value of T1. Put it in this part, you will get the value of T2. Try to solve. Good, Samira. Good, Mariam. Sofan, send me your answer. Arslan. T1 sine 30 is 1 by 2. Mass, gravity is 10. This 2 will move to other side in numerator. So T1 will be 2 into 5 into 10. So it will be 100 Newton. Now, if you put this term in the second equation, T1 is 100. Cos 30 is root 3 by 2. So this 2 and this 100 will cancel out. So you will get 50 root 3 Newton. Is it clear?
Yes, sir.
Okay. We may use Lemmy's theorem for this part. Suppose this was your first string, this was second, and there is gravity along this direction. So this will be tension T1, tension T2, and this will be mass times gravity mg. So for Lemmy's theorem, we have to first define angle between each term. Inclination between these two terms is 90 degree. If you draw a horizontal line to this will be 30 degree and this will be 90 degree. So total angle from this point to this point will be 120 degree. And left out portion from this point to this point, it will be 150 degree. Now, if you apply Lemmy's theorem to this, you'll get T1 divided by sine of opposite angle, so sine 90. T2 divided by sine of opposite angle, that is 120 degree. And F3 divided by sine of opposite angle, this is 150 degree. Is it clear? Now just compare first and second. You'll get the value of T1. Then compare first and third, you'll get the value of T1. Now in this part, you have to find the value of sine 150 degree and 120 degree. Sine of 120 degree equals to, first rewrite this angle in terms of 180 degree. So it will be 180 degree minus 60 degree. So according to the rule of trigonometry, we may write it as sine of 60 degree, as this 180 degree will defines you horizontal line on which there will be no change. And since this whole angle will lie in second quadrant where sine will be positive, so it will be root 3 by 2. Similarly, sine of 150 degree is equals to sine 180 minus 30. So it will be sine of 30 degree, which is equals to 1 by 2. So if you put these two terms in this expression, you will get T1 and T2 directly. So for these type of problem, we may use two different methods. First is resolve or vector resolution method, which I have used above. And second is using Lemmy's theorem. So far, is it clear?
Yes, sir.
So you may write T1 equals to sine 150 degree into sine 90 degree, and T2 equals to mg just write it down.
Done, sir.
Arslan,
Done.
do you have any doubt?
No, sir.
Okay. Mariam, you got the same result as above for T1 and T2?
Sir, I'm solving.
Okay. Mass is 5, gravity is 10, sine of 150 is 1 by 2, and sine 90 is 1. So this 2 will move to numerator. So you will get 100 Newton. For the second part, mass is 5, gravity is 10, sine 120, it will be root 3 by 2, and sine 150, it will be 1 by 2. So this 2 and this 2 will cancel out. So you will get 50 root 3 Newton. Is it clear?
Yes, sir.
Yes, sir.
Aisha, do you have any doubt?
No, sure.
Okay. You all have written?
Yes, sir.
Safal? Suppose a string having mass m is initially along this direction. Now force is applied to bend it like this. Force is of 40 Newton. Mass of this block is 3 kg. So you have to find this theta. just use the previous concept of resolution and try to find the value of theta. Draw a vertical line and horizontal line. There will be tension in this direction, T. This angle and this angle will be equal according to alternate interior angle. Now, resolve the component of this tension with respect to theta along vertical and horizontal path and equate them. You will get the value of theta. On resolving this component, it will be t times cos theta as it is adjacent to theta, and it will be t times sine theta. So on comparing, t sine theta will be 40 and t cos theta will be mg, that is 3 into 10, 30. Just divide these two terms and try to find theta. Since there will be a force in downward direction, that is mg. So total force in this particular string will be due to this part. Mass is 3, gravity is 10. Arslan, is it clear?
Yes, sir.
On dividing these two terms, t and t will cancel out. So sine theta divided by cos theta, it will be tan theta equals to 0 and 0 will cancel out. So it will be 4 by 3. Now, if you compare this particular ratio in this triangle, 4 will be perpendicular for 53 degree. It means theta will be 53 degree. Mariam, is it clear?
Yes, sir.
Sabita, any doubt?
No, sir.
You all have written?
Yes, sir.
Arslan?
Yes, sir. Done.
Okay. Now the next term is about a reference frame. In last chapter, in relative motion, where we were defining motion of a body with respect to some other reference, which must be moving with some velocity or some acceleration and so on. In this part, we have to define forces related to that particular reference. So we may define reference frame in two different ways. First is inertial frame of reference, and second is non-inertial frame of reference. Inertial means if a system having zero velocity or some constant velocity for which there will be no acceleration, that will be termed as inertial frame of reference. If velocity is zero or constant, so that acceleration of system will be zero. Is it clear?
Yes, sir.
Yes, sir.
Second is for non-inertial part, velocity will be variable and then there will be some acceleration of system. Due to this acceleration of system, there will be some amount of force acting on the system, due to which there will be change in inertia of that particular object. So a force will develop into it on the object due to change in state, direction, or shape. That force is termed as pseudo force. Let me define you. Suppose your block like this, or a plane surface like this, and there is a block placed over it like this. Or take your notebook like this and place any object on it. Let's say your pen, and gently shake it in forward direction or backward direction. You will observe pen will move opposite to your jerk or motion. Is it clear?
Yes, sir.
So if you accelerate this particular plank in forward direction, so with respect to this, you will feel the block will move in opposite of it. Is it clear?
Yes, sir.
But in actually, since you are pushing this particular block from its own position towards the right, this block, due to its inertia of rest, it will remain to its rest at this point. But I'm observing from this end, so you will feel the block has displaced from its initial position slightly leftward. But in actual, there will be no displacement in the block. There will be displacement in this particular plank only. Is it clear?
Yes, sir.
So you'll say, when a system accelerates with some acceleration, there will be a concept of pseudo force, which is due to inertia in that particular block. So you'll say a force will develop or tends to behave in this particular block, which will be in opposite sense of motion of system. So a force which develops in a body due to acceleration of system in opposite direction due to inertia is called pseudo force. Is it clear?
Yes, sir.
Arslan, is it clear? You all have written?
Yes, sir.
Yes, sir.
Sabita, any doubt?
No, sir.
Okay. So let's stop here for today. In next class, I will continue with this part and I will complete it. From next class onward, I will prefer to go with the second term syllabus first, and then on completing that, we'll again continue with this part. Is it clear?
Yes, sir.
Yes, sir.
Okay, then we'll meet in next class.
Thank you, sir.
Thank you, sir.
Thank you.
User.
Thank you.